Hi everyone, thanks for watching another CurioCat video. In the last video, we left off with independent sources, so in this video, we will start with dependent sources. In this example circuit, I have an independent voltage source, and it is independent because it has a circle shape, and I also have a dependent current source, so dependent sources have a diamond shape. And in this case, it's a current source because there's an arrow shape inside the diamond. Now notice that I have a current IB, which I've colored in blue, and IB flows in this counterclockwise direction up until this point here. I have another current which I've labeled IG, and I've shown with this green arrow. So IG starts down here, and it flows in the same direction as the current source, and it keeps flowing until this point here. So at this point over here, the currents IB and IG meet, and these two currents have nowhere to go except to go down this way, where I have drawn a current IR denoted with a red arrow. So because IB and IG meet to form IR, we can say that IB plus IG must equals to IR. Okay, so when the current IB flows past this resistor over here, it causes a voltage drop across this resistor of value VB. Now imagine that the dependent current source over here has a value that's dependent on VB. That would make this current source over here a voltage dependent current source. For example, we can make it so that this current source has a value of 0.25 times the voltage VB. You might wonder how it is possible that the voltage VB can dictate the value of the current source. The answer is that there's a hidden circuit connecting the voltage VB to this current source over here. Okay, so how does that work? The answer is that this current source is made up of an element known as a transistor, and a transistor is a device that takes a voltage as an input and creates a current as an output. So the current IG is the output of this transistor. So if you were able to attach a wire between the positive end of the voltage here and the positive end of this voltage here, and another wire between the negative end of this voltage here and the negative end of this voltage here, then that means that you can use the voltage VB as an input to this current source. Here I have made the aforementioned connections using a purple and pink wire, and you see over here I have drawn a little hump shape in this purple wire to indicate that the purple and pink wires should not touch. Inside this current source, there is a transistor and other circuitry that you can adjust so that the current IG will be exactly 0.25 times VB. But learning the inner workings of this current source is not something that you would cover in introductory circuit analysis. As a result, your book will not show this connection between the voltage VB and the current source IG. Instead, your book will only show this circuit. Now, we will move on to the current dependent current source. This is just the same thing as the voltage dependent current source, because if this current source is dependent on the voltage VB, then this current source is also dependent on the current IB, because the voltage VB is related to IB through Ohm's law. Similarly, you could also have a voltage dependent voltage source or a current dependent voltage source. The next circuit element we will discuss are switches. In the circuit shown, there are three switches, S1, S2, and S3. Switches can be in the open or closed position. As shown, all three switches are in the closed position. As a result, current can flow anywhere in this circuit. Now what happens if you open a switch? For example, if you open S1, The answer is that you may create a dangling wire where no current can flow. Here I have used some purple X's to show a dangling wire where there can be no current. This means that we can pretend that this part of the circuit does not exist and we can remove it. For our next example, we have opened switches S1 and S2. As a result, we have created two dangling wires where there can be no current. These wires are marked with the purple X's. As a result, we can pretend that these two dangling wires do not exist and we can remove them from the circuit. In the last example, I will open all three switches. I will use purple X's to label all of the dangling wires. Again, these dangling wires can be removed from the circuit. There are other circuit elements such as potentiometers, transducers, capacitors, inductors, and more. However, we will discuss these as they arise. Alright, that's it for this video. Watch out for chapter 3. That's when I will teach you how to actually solve for all of the voltages and currents in a circuit. If these kind of videos are useful to you, then please like, comment, and subscribe. And if you have any questions, then please leave them in the comment section and I'll get back to you as quickly as possible. And thanks for watching.